prefabricated T-sections include a custom hanger attachment to allow these sections to be supported by the curved box sections of the large arch supports. The architectural use of express tensile cross-bracing was well established in the design of the Pompidou Center by Piano and Rogers. The creation of the connection detail at the center of the transfer of forces has generated some interesting solutions. Here, the rods are accepted by a section of round HSS with a simple cover plate to hide the bolts in behind. Steel is often used to brace timber structures, as in the case of this exterior walkway. This project takes a different approach to the design of this connector, altering the reading of the architecture on this exposed exterior bracing system. Galvanized steel has also been used for corrosion protection. This very lightweight facade at the Munich International Airport required cross-bracing to provide rigidity. The cross-bracing triangulates the structure, with only one diagonal acting in tension at a time, as a function of the lateral loading on the building. The designers decided to use pairs of tension connectors to achieve the cross-bracing as part of this design. If you look to the upper left-hand rod, you can see a very slender turnbuckle. These systems must be installed loose and tightened in place using the turnbuckle. The large custom trusses at the Burj Al Arab use cross-bracing as part of the system design. The design of the plates to transfer the loads across the center of the cross-bracing have been designed to be very slender to make them less apparent in the design. The Munich Olympic Stadium is an early example of the use of a mast and suspension system. There is a very obvious contrast in the nature of the compressive mast structure with that of the large cable suspension system that gives form to this glazed roof. The system clearly differentiates the loading on the members, assigning much more substance to those in compression and using lighter cables or rods for those in tension. Custom connectors were fabricated to serve as the clevis attachments, as these were not yet in regular production at that time. The Munich airport also makes use of a tensile system to brace the masts and support the glass and fabric roof of this convention structure. From a design perspective, the light steel members match the light nature of the fabric roof and its form. It is easy to see that the triangular tubular masts are acting in compression, and the cables acting in tension by virtue of the sizes of the members. Where the glass and fabric roof meets the mast, the different steel systems are differentiated by color, the gray of the support system for the roof glazing allowing the white of the mast structure to visually dominate. The light cross-bracing system for the glazing is almost imperceptible when viewed from the ground, yet essential for stability. The glass and fabric roof of the Sony Center is supported by a cable and mast system. The mast is made of heavier steel sections and is acting in compression. The system in this case is suspended in midair and is braced back to the circular truss at the upper edge of the surrounding buildings. The resolution of the connection of the numerous tension members to the base of the mast is quite innovative. The plates are spaced apart to permit welding to the center of the post. The plates are angled to narrow to match the size of the clevis. As there would not be enough steel at the point of attachment of the clevis, the plates are thickened to provide the necessary steel to resist the pull-through forces. This highly unusual bridge in Brisbane, Australia, is created from a tensegrity-type structure. Here, the contrast between the member sizes of the compression masts and tensile members is taken to an extreme contrast. The roof of the covered walkway is also suspended from the mast and cable system. The angles make this a dynamic space to walk through. The detail at the top of the mast is designed to accommodate the attachment of the clevises. You can see that the plates are differently sized to respond to the loading. Also, the plates have been thickened precisely where the clevis overlaps to provide the additional steel that is required to resist pull-through forces. This detail at the base of the connections reveals the large scale of the clevis attachments and the thickening of the plates again to resist forces. Tension systems have become very popular for their ability to create expansive coverings of a lightweight and sculptural nature that take advantage of their structural